Okay, today we are going to discuss the third unit, that is the tension members. Okay, these are the contents of this chapter. This first is introduction, then second we have to then behavior of tension members, in that plates under tension, then second is threaded rods, angles under tension. Next we are going to study what are the codal provisions as per the IS 800 2007, that is the revised codes for the steel structures, and lastly the summary. Okay, so what is meant by tension member? That is first, it is a structural member which is subjected to pulling, or it is called as a tensile forces applied at its ends is called as a tension members. Okay, structural member which is subjected to the two pulling forces, that is tensile forces which is applied at the its ends is called as a tension members. Okay, these are the general live structures. Okay, having the tension member is there. First is your roof truss. In roof truss, the bottom member, that is a tie member, is your tension member. Then in case of the suspended buildings, okay, outer members, these are again the tension members. These are the practical applications of the tension members. Then third is your roof purlin systems. Okay, top member of the truss is your principal rafter. Then on the top member you are providing the purlin sections. Purlin may be the angle sections, or maybe the channel, or maybe the eye section, and these two purlins are connected with the sag rod. Sag rod, it is again the tension member. Okay, and last is the braced frames. Okay, in case of the multi-story structures or in case of the industrial structures, okay, you are providing the bracing systems. Okay, to predominantly carry the wind loads which is coming on the structures. In that case, the bracing members is designed as a tension members. Okay, these are the some practical examples of the tension members in a buildings. Okay, the members, that is tension members, and the connection is so arranged that eccentricity in the connection and the bending stresses on the member are not developed. Okay, the strength and or efficiency of tension members may be seriously affected because of the end connections, maybe the bolt holes or maybe the riveted connections, in the shear lag or the reversal of loads which causing the buckling and the bending moments, the bending moment due to the eccentricity in the end connections or lateral loads on the members. Okay, theoretically, when I'm talking, a member subjected only the axial tension is supposed to be most efficient and economical structural element. Why it is? Because the member does not buckle locally or overall up to and beyond yield, and also because the entire section is subjected to the uniform stresses. This is just a brief idea about the tension member. Okay, the next in introduction, first is the characteristics, in that how the member experiences axial force and stretching and uniform stress over the cross section. The next is a very efficient member, that is the strength which is governed by the material strength, and bolt holes affect the strength. Okay, for ductile materials, because it is ductile material, a uniform stress distribution assumption is reasonable when the material is loaded beyond the yield stress. Okay, therefore at the ultimate load it is reasonable to assume uniform stress distribution. Okay, then these are the general cross sections which are used for the tension members in different types of the structures. First, commonly using the angle sections and the double angle sections in case of the roof trusses, or in case of the transmission towers, or in case of the telephone towers, you can use the angle sections, maybe the single angle section or maybe the double angle section. When you're providing the double angle section, the sections may be placed back to back on opposite side of gusset plate or on the same side of the gusset plate. Again, you have to also provide the channel section and eye section as a tension member, then rod, then cables, then a built-up sections. Built-up section is nothing but the section which is formed using the two or more sections. Okay, the sketch is showing that the two channel sections which are placed face to face, and above that there are the two cover plates are there, which is connected with the bolted connection or the welded connection, and the second again built up section, that is two eye sections with the top cover plate and bottom cover plate. Okay, these are the general commonly used sections as a tension members. Okay, then the behavior of the tension member, how the tension member or the steel is behaving. Okay, you have studied in second year in structural mechanics 1. Okay, that is stress strain curve for the mild steel. Okay, stress strain curve for the mild steel. The stress strain curve for mild steel presents a lot of information that is necessary to understand how it behave in a given situation. Therefore, for a steel design method to be satisfactory, it is essential to be conversant with the stress strain relationship of the mild steel. Okay, this is engineering stress strain curve. Okay, the curve A, B, C, D, E, okay, represent the stress strain curve when a mild steel specimen is subjected to the gradually increasing tensile load. Okay, the various elements of the curve as shown in figure, that is 0.2% is your proof strain, and yield plateau is there, that is for the mild steel, and upper graph, that is for the high strength steel. Okay, so already you have studied in secondary level, that is in structural mechanics 1. Okay, the next is the behavior of a tension member. Okay, the sketches is showing that it is behavior in elastic, then in second in elastic plastic, and third is the ultimate. Okay, elastic means you are considering the load up to the yield point, then elastic plastic. Okay, then beyond the elastic and before the plastic state, and ultimate means whole section in a plastic state. Okay, this you have studied in second unit, that is the introduction of your limit state methods. Okay, what is elastic, elastoplastic, and ultimate. Then the behavior of the tension. Okay, when you connecting the tension member with the gusset plate. Okay, the member which is connected to gusset plate with the bolted connection or the weld connection. In this case, the gusset plate or the tension member is connected to the gusset plate by using the two bolt holes or the two bolt. Okay, D is nothing but the diameter of bolt hole, and B is nothing but the width of the plate. Okay, that is for the case A. Okay, case A, how you calculate the net area? Net area is equal to thickness of plate into width of the plate minus 2 times the diameter of the bolt hole. That is for the case first. Okay, that is a chain pattern. First is your chain pattern, then case B. Okay, then in case B, net area you have calculated, that is thickness multiplied by the width of the plate minus diameter of bolt hole. And in third case, that is for the staggered pitch, you have to calculating the area. Okay, the area in case C is greater than area of case A, and it is less than the area of the case B. Okay, that is T into B minus 2 into D is less than area for the third case, that is for the staggered case, which is less than T into, that is thickness of plate, multiplied by B, that is width of plate, minus D is your diameter of bolt hole. Whereas P is nothing but the pitch and G is nothing but your gauge distance. Okay. Then this is again the plates with the holes. Again these are the staggered pattern. Then you have to calculate the net area required. This formula is given in IS 800/2007. Then net area, that is AN, is equal to width of the plate, that is B, minus N times D. N is nothing but the number of bolt hole in that particular pattern into diameter of bolt hole, plus summation of P square, that is the pitch square, divided by 4 times the gauge distance and hole multiplied by the T. If you are providing the staggered pattern in case of the plates, then you have to calculate the net area by using this formula. Okay, next is the behavior of the tension member. Okay, when the angles are eccentrically loaded to the gusset plate. suppose take example that single angle which is connected to the gusset plate with the bolted connection. Okay, then revised IS 800 2007 section 6. In IS 800 2007 section is for the design of the tension member. In that 6.1 is for the tension member, that is introduction of tension member. Then 6.2 is for design strength due to the yielding of cross section. And 6.3 is design strength due to the rupture at critical section, which includes plates, threaded rods, single angles and other section. Then 6.4 is for the design strength due to the block shear. In that for the plates and angles. Then what are the design procedures or different clauses which is given in IS 800 2007, that is codal provision for the tension members.